Hi guys, in this video we're going to look at another method for solving systems of equations, and this method is called elimination. So here are the steps for using elimination. So we're going to line up our system so that like terms and equal signs are aligned. So lining up our x's, our y's, and then our constants. We're going to multiply one or both of the equations so that the x's or the y's have the same coefficient. So remember, a coefficient is just the number in front of a variable. So we want those to have the same coefficient, but opposite signs. So one being positive and one being negative. We are going to add the two equations together after we do that, which will eliminate one of our variables, which is why we call it elimination. Oh, eliminating, probably get our grammar right here. Eliminating one of your variables. Solve the resulting equation. And then we're going to substitute that variable into either original equation and solve for the remaining variable. And then, as always, we'll write our solution as an ordered pair. Okay, so let's follow these steps here on number one. Line up your system so that all like terms and equal signs are aligned. So x's, y's, equal sign, constants. That is all perfectly lined up. Now, we want the coefficient to be the same, but opposite sign on either the x's or the y's. So we actually already have that. So look right here at our x's. They both have a coefficient of 4, but one is positive and one is negative. So when that happens, we don't need to multiply. It's already how we want it. So when we have same coefficient but opposite signs, we can go ahead and move to step 3. We're going to add the two equations together. So add the x's. So adding the same coefficient but opposite signs, those are going to cancel, which is this piece. It's eliminating one of our variables. So we just eliminated the x's. Now negative 2y plus 8y is 6y. And negative 12 plus negative 24 is negative 36. So now we're on step 4, solve this remaining equation, which is pretty nice. It's just one step, divide by 6 to get y by itself. So I get y equals negative 6. Now remember, systems, we need the solution for x and for y. So we found the y, we need to get x. So this is step 5. Substitute this value back into one of the original equations and solve for the other variable. So in our case, x. So I'm just going to use the top equation. So we have negative 4x minus 2y, but we know y is negative 6. Okay, and then we're going to solve this for x. So we have negative 4x plus 12, when I multiply those two, equals negative 12. Subtract 12 from both sides, and come up here. So I've got negative 4x equals negative 24, divide by negative 4. We get x equals positive 6. So here's my x, here's my y, so my ordered pair is 6, comma, negative 6. All right, okay, let's try number 2. So we want the same number but opposite signs. So this one's really close. They're both 2, but I need one of them to be negative. So I need to multiply one of the equations by negative 1. So it doesn't matter which one. Let's say I just want to multiply the top one. So I want to multiply this whole equation by negative 1 so that this will become a negative 2. And then negative 2 and positive 2 would cancel. So, but I have to multiply the entire equation by negative 1. So I'm going to write my new equation below here. So negative 2x, negative y, and negative 1 times negative 5 is positive 5. So my x's are lined up, y's are lined up, constants are lined up, and I have same coefficient but opposite signs, so now I'm going to add the equations. X's are going to be eliminated. Negative 5 plus a negative 1y is negative 6y. 13 plus 5 is 18. Solve for y, so divide by negative 6. So y equals negative 3. Now to get x, we're going to take negative 3 and plug it back into one of the originals. I'm just going to use the top one again. So 2x plus y, but we know y is negative 3. Okay, so I can add 3 here, get rid of that. So I now have 2x equals negative 2. Divide by 2, and I get x equals negative 1. So then my ordered pair is negative 1, negative 3. All right, try a couple more here. Okay, so in this one, I want to eliminate a variable here. So these are opposite signs, but not the same number. So this one, maybe I would choose to multiply by 2. And again, I can do the whole equation by 2. So then I would get 2 and negative 2 there. So leave the top equation, so I'm just going to rewrite it. Okay, now I'm multiplying this second equation, everything by 2, so this is going to be negative 2x plus 6y, and then equals negative 24. Okay, same number, opposite signs, add, eliminate. 1y plus 6y is 7y, and then I get negative 21 when I add 3 to negative 24. Divide by 7. Y is negative 3. Plug in y into one of the originals, so 2x plus negative 3 equals 3. Add 3. So I get 2x equals 6. Divide by 2. X equals 3. So 3 comma negative 3 is my solution. All right, in this one, man, I just keep eliminating the x's here. So this one, if I multiply this x by 3, I would get both to be negative 9. So if I multiply this by negative 3, this would be a positive 9 and a negative 9. So again, I'm going to eliminate my x's. So I'm going to multiply this whole equation by negative 3. So this one will become a positive 9x. Negative 3 times 7 is negative 21y. And then negative 3 times 16 is a positive 48. All right, so here's these two now that we're going to add. Eliminate the x's. 5 plus negative 21 is going to give me 16, negative 16y. And 16 plus 48 is 64. Divide by negative 16. And when we do that, we get y equals negative 4. Plug into the original equations. So I'm going to use the top one again. So negative 3x plus 7 times negative 4 in for y equals negative 16. Negative 3x minus 28 equals negative 16. Trying to get x by itself now here. Negative 3 equals, what do we get there? 12. And then divide by negative 3. So we get x is negative 4. Both x and y are negative 4, so my ordered pair, negative 4, negative 4. All right, we got 2 more examples here, you guys. All right, so in this one, actually both of these, I think we're going to have to multiply both equations in order to get the same coefficient. So you can choose either x or y, it doesn't matter. Let's go ahead and eliminate the y's this time. We've done all x's. So I want to get a common coefficient here. And already I have one that's positive, one that's negative. So 5 and 4 both go into 20. So I want to make them have a coefficient of 20. So to do that, I need to multiply this whole equation by 4. That will change my y to 20. And this whole equation by 5. That will change this one to negative 20. And then we would be good to eliminate. Multiplying everything. So 4 times 2x is 8x. 4 times 5y is 20y. That's the one we're going for. And 4 times 26 is 8104. Okay. 5 times everything now in the bottom here. So I've got negative 15x. 5 times negative 4y is negative 20y. So there we go. We got our opposite coefficients. And 5 times negative 25 is negative 125. All right. So now that my y's are opposites, opposite sign but same coefficient, we can add. 8 plus negative 15 is negative 7x. Y's are eliminated. And then 104 minus 120, or plus a negative 125, let's see there, we got 21, negative 21. All right, and now divide by negative 7. So we get x equals positive 3. Now we're going to plug our x into one of the originals, so 2 times x, or 3, plus 5y equals 26. 6 plus 5y equals 26. Subtract 6 now. 5y equals 20. and then divide by 5 to get y equals 4. So 3, 4 is my solution. All right, we got one more. All right, and this one, we notice my x's and y's are not lined up. So I'm going to rearrange my bottom equation first, just to make sure that it's all lined up. So usually we had our x's and our y's on the left, and then the constant on the right side of the equal sign. So I'm going to go ahead and add 2x over to the left. So I'm rewriting my top one first. So there's negative 5x plus 2y equals 32. Now my bottom equation, I rearranged. So I added 2x to the other side, so it's a positive 2x. That's a positive 3y, and then equals 10. I still have 10 left. So I had to rearrange it so that my x's, y's, and constants all lined up. Now I need to worry about getting them to be the same number. Okay, let's go ahead and eliminate y's again. So 2 and 3. So I need something that they both go into. So 6 would be a good one, but I need one to be positive and one to be negative. Doesn't matter which one you decide. So let's say I want the top to be positive and the bottom to be negative. So I'm going to multiply this by 3. So that will give me a positive 6. But this one I'm going to multiply by negative 2 because that'll give me a negative 6 for the y there. Okay, so I'm going to do 3 times negative 5x to get negative 15x. 3 times 2y is 6y. 3 times 32 is 96. Now I'm doing negative 2 times everything in the bottom equation. So negative 2 times 2x is negative 4x. Negative 2 times 3y is negative 6y, which is what we want. Oh, my eraser is terrible, sorry. All right, negative 6y. And then negative 2 times 10 is negative 20. Add, y's are eliminated. So I get negative 19x. And then 76, when I add those two, divide by negative 19. And I don't know that one off the top of my head, so 76 divided by negative 19 is negative 4. Okay, have x, so take our x, plug it back into the original. So negative 5 times our x is negative 4 plus 2y equals 32. Positive 20 there. Now I get y by itself here, so we'll subtract 20. 2y equals 12, and divide by 2. Y is equal to 6. So negative 4 and 6, so my solution is that ordered pair. All right, so that is the process of elimination to solve systems of equations. Thanks for watching.